Okay guys, let's get this show on the road. Today we're going to talk about data collection and analysis. Accuracy is the degree of conformity with a standard, often called a true, accepted, or theoretical value. There are times when a calculated value will be used as our standard. Now, accuracy is how close you can get to that standard, or that true value, or the accepted value, or the theoretical value. So up here on this bullseye, if the standard was right there in this red area, then this arrow would be accurate. All right, precision is how close measurements are to one another. Repeated measurements determine reproducibility or precision. Precision tells you how to report results. So data is precise if it's close together. All right, now let's look at these four bullseyes. We're going to determine if it's accurate or precise. Right here, this red dot, we're going to consider that the true value or the standard. So when we're talking about accuracy, if it's close to the true value or standard, then it's accurate. Okay, so these three dots right here, they are not close to the true value, so they are not accurate. Not accurate. But these dots are all close to each other, so they're very precise. So this set of data is precise. Now let's look at this set of data. Each one of these dots are fairly close to the accepted value. All right, now let's look at this bullseye. All three of these dots, or three of these data, are fairly close to the accepted value right in here. If you took all of them and you averaged them together, they would be right here in the middle. So that would make this accurate. This data is accurate. Okay. Now, the dots are not close to one another. Okay. They are more than one area away. And if they are, like this is one area, this is one area, this is one area. If they're more than one area away from each other, then they would not be precise. So this is not precise. Okay, let's look at this bullseye. These three data points are very, very close to the accepted value or the standard. We would consider this accurate. And they are also very close to each other. So we would consider this set of data precise and accurate. By the way, this is what we strive for when we get data. When we run our lab experiments, this is what we like. We like for it to be, our data to be accurate and precise. Okay, now let's look at these three pieces of data. None of them, not one piece of data, is close to the accepted value, so it is not accurate. And I'm looking at this thinking, I don't know how to spell accurate. There's only one R and two C's. Okay, now let's look. Are they precise? Are they close to each other? No, they are not. Okay, so it is not accurate, not precise, it's neither. All right, we do not want our data to be like this. This is very bad data. Okay guys, now let's look at this set of data right here in group 1. Now our standard is 79 degrees Celsius. So if it's close to 79, then we're going to be accurate, okay? The average of these trials is close to the accepted melting point of 79. So it would be accurate, okay? Now, they are not close to each other. Close to each other would be no more than one of these away, okay? So we're going to look at the second to the last number. Now, if they differ more than 1 point, then it's not going to be precise. So this is just accurate. Now let's look at number 2. 76.2, 76.1, 76.3. That is not close to 79 because it differs more than 1 degree. But they are all within 1 degree of each other, so that would be precise. Now number 3. 86.4, 82.8, 81.2. None of them, the average, is not close to 79. It differs by more than 1 degree. And they also differ by more than 1 degree from each other. So this would be neither. Last one, 79.1, 78.9, and 79.2. None of these All of these are close to 79, and they're also close to each other. They're within 1 degree, so they are both. Okay, qualitative measurement. We touched on this in Unit 1. We're going to touch on it again. It's a non-numerical or descriptive data, like color, texture, etc. Also, when we talk about qualitative measurements with lab equipment, the big word that we're going to look at is approximate. Okay, so if it has an approximate value, or it's approximately 50 mils or approximately 50 grams, even though it has a number, if it says approximate, that means it's qualitative. Now remember that L means looks. Okay, quantitative is the quantity, and it is a number. Numerical information, anything that contains numbers. And also with lab equipment, we're going to say it's a quantitative measurement if it is a precise measurement, if it measures precisely. So I'd like for you to write that down in your notes as well. Okay, so now let's look at our glassware. We're going to see if it's a piece of qualitative or quantitative piece of glassware. So I've highlighted these for you, and I would like for you to highlight these or underline them in your notes so you know it's approximate. And remember, approximates are qualitative. Okay, I'm just going to put qual because I'm lazy. A burette is used to precisely deliver, so it's going to be quantitative. An Erlenmeyer flask holds approximate volumes, qualitative. A graduated cylinder used to measure and deliver precise volumes, it is quantitative. Pipette, precisely deliver, that is a quantitative piece of glassware. Test tube, it says a glass cylinder that holds liquids being tested in an experiment. It doesn't say anything about approximate or precise, but it doesn't say that it measures anything. So if it just holds, it's a qualitative. Okay, volumetric flask is precisely, so it is quantitative. Explain the process of making a detailed measurement. First thing you're going to do is estimate between the lines. If the measurement is on a line, you're going to add a 0 to show that you are estimating to be exactly on the line. Always include one estimated digit. Let's do A and B together, and then you do the rest on your own. Okay, A. It is between 0 and 1. And by the way, these are in centimeters. It doesn't say, but I'm going to write down here it's centimeters. So we're between 0 and 1. Now I'm going to show you how to figure out what each one of these markings is worth, okay? So the first thing you're going to do is you're going to take your higher number minus the smaller number, which is 0, and you're going to divide it by the number of markings that it takes to get there. So let's start at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 markings, so you're going to divide that by 10. 1 divided by 10 is the same thing as 0.1 or a tenth. So each one of these markings is worth 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5. Right here. But it appears that this is right there. A is right there. It's not on the line. So now we need to estimate this next digit right here. It's not quite halfway in between, so we're going to choose a number less than 5. So I'm going to choose, I don't know, how about 0.52? Okay, if you said 0.53, that would be okay. 0.5, excuse me, 0.51 is okay. Now, this number you know, this is your estimated digit. That's the one that you're uncertain about. That's the one you're guessing. All right, now let's do B. B is 0.5, 0.6, 0.7. Whoops, I can't draw a straight line here. All right, so we're at 0.7. We know that number for sure. Now we need to estimate this. And I don't know, what do you think? It's less than halfway, so it's going to be less than 5. I'm going to say 0.73. Whoops, 0.73. All right, I know it's less than 1. I know it's at least at the 0.7 mark. this is the number that I'm guessing. It could be 0.74 and I'd be okay with that. If you put 0.72, I'd be okay with that as well. Now what I would like for you to do is pause the video and go ahead and do C through F. Write them down on your notes. Now remember, if it's exactly on the line, if it looks like it's exactly on line, your estimated digit is going to be a 0. Pause the video, and then the next slide is I want you to check your answers. Okay, that should not be a 9. It should be around a 3. Go ahead and check your answers here. Now remember, this is on the line, so the estimated digit is going to be 0. Same thing here. You could have 1.59, that would be okay. 1.57 would be okay too. How do you take measurements when a meniscus is present? From the bottom of the meniscus. This is the meniscus right here, this curvature of a liquid, and you always take the measurement from the bottom, not up here. So when you're at eye level with the meniscus, this is where you take the measurement. Burettes measure the amount of liquid that is released through a stopcock. A graduated cylinder measures how much liquid it is holding. You can tell the difference between a burette and a graduated cylinder because a burette will be marked upside down. The numbers will increase as you go down. So look, here's 22 mils, here's 23, the numbers are getting bigger, 24, 25. Compared to a graduated cylinder where the numbers increase going up. So you've got 5 mils here, 10, 15, 20. All right, let's look at this apparatus, and the first thing you're going to do when you look at this is try and determine, is it a burette or is it a graduated cylinder? Now the numbers increase going up, which means it is a graduated cylinder. Graduated cylinder. We started out at A, we poured some out of the graduated cylinder, and we ended up here at B. We need to take A minus B to find out how much liquid was released. So the first thing you're going to do is find out what each one of these markings is worth. So we're going to take the bigger number minus the smaller number and divide that by the number of markings in between. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 40 minus 30 is 10. 10 divided by 10 is 1. So each one of those is worth 1 mil. And it doesn't say it on here, but these are milliliters. We also call them mils. All right, so this is 30, 31, 32, 33, 34, 35. Right there. And it looks to me like B is right on the line, so I'm going to not just put 35. Remember, I've got to estimate an extra digit, okay? Because I know it's at least 35. 36, 37, 38. So A is at 38, and now I need to estimate another digit. It's pretty close to the line, so I'm going to say 38.1. Okay, I'm going to take 38.1 minus 35.0, and I've got 3.1 milliliters has been released. Okay, if you got 3.2, that would be okay. Or 3.0. Let's go to the next example. Okay, so the first thing you're going to do is find out, is this a burette or a graduated cylinder? And the numbers increase as you go down, which tells you that it is a burette. All right, so we started out at this amount and we ended up with this amount. So the first thing we're going to do is find out how much each one of these markings are. So 20 minus 10 and divided by the number of markings in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20 minus 10 is 10. 10 divided by 10 is 1. So each one of these markings is worth 1 mil. So initially we have 11, 12, and then we're going to measure right here at the bottom of the meniscus. It looks like to me that it is 12 point, now we need to guess. I'm going to say it's not quite halfway. I'm going to say 12.4. If you say 12.3 or 12.5, that's okay too. 13, 14, 15. Now this one looks like it's right on the line. So I'm going to guess 0.0. It could be 14.9 and it could be 15.1. Now, to find out how much is released, we're going to take the bigger number, 15.0, and subtract it from the smaller number, 12.4, and that is equal to 2.6 milliliters.